Hello. Today we are discussing about slope deflection method. Up till now what we are talking only something about the external load that we are discussing so far and taking the moments at A, B and supports. But here this is not the case. When we are talking about the slope deflection method, not only the external load moments, but because of the rotation at one support, what is the moment at A and the effect of that rotation, what is the moment at B. Similarly, when the support B is rotated some angle theta B, what is the moment at B and what is its effect on A, that is we call MAAB, and because of the deflection or sinking of A, what is the moment because of the sinking over here and because of the sinking over here. All four types of moments are to be considered on each and every joint, each and every support. Now this is the basic concept for calculating the slope deflection method and by which we can find out the moments. Now we'll start with one problem which I am taking as a continuous beam with support A as a fixed one, support B intermediate support and support C again a simple support at the end. With a in between support A, B there is a point load acting at a distance of 2 meter and 3 meter with a total span of 5 meter. Between B and C a uniformly distributed load of 20 kN per meter. But before we start, there are certain points that is to be noted, the important point that is to be noted. When the support is fixed, then there is no rotation and hence we can say that theta comes out to be 0. When the end support is simply supported, then sum of all the moments at that support is 0, just like in the case of this support C. Whatever types of moments which are acting over with the total sum comes out to be 0. Similarly, unless and until given, if the deflection is not given, means no deflection is there, this minus 6 EI delta upon L square turns out to be 0. We need not to consider the moment because of the deflection. Now, when we start with this continuous beam, we have to bifurcate each span separately like this. First of all, we talk something about the AB and then we will talk something about the BC. First of all, when we are talking about the AB, we have to calculate first of all the fixed end moments at A. Because of point load, it will be minus WAB square upon L square, everyone knows very well. Substitute the value of W as 40, A is equal to nothing but this 2 and B is nothing but equal to 3. So WAB square upon L square, it comes out to minus 28.8 kilonewton meter. Now, there is no, because the support A is fixed, so there is no rotation at theta A, so the moment because of theta A is neglected, but there is a rotation at B. And when we talk about the rotation of B, the moment because of the rotation at B is known as 4 EI theta B by L, but the half the moment will be transferred over to A and it will be nothing but it will be taken as 2 EI theta B by L and it is nothing but 0.4 EI theta B. Because 2 EI theta B by L is known as pi. We have already mentioned that the rotation moment at A due to rotation at B, theta B at B will be equal to this much. So, only because of the rotation at B, if we have taken into consideration. And hence the total moment of BA will be equal to nothing but minus 28.5 plus 0.4 EI theta B. This is the sum of all the moments about A. Now we'll go for next part, that is BA. Now we are considering support B. Now here we find there are fixity moment because of this load at B, at A as well as at B. Similarly, because there is no rotation over here, but rotation is over here, so we can find the rotation is over here, but no rotation over here. The moment because of this, so we have to find out two types of moments. One because of the fixed moments, because of this point load, and another because of the rotation at B. So, MFBA, fixed moment at BA, is plus WBA square upon L square, and B will be 3, A will be 2, WBA square upon L square, it comes out to plus 19.2 kilonewton meter. Now, moment due to rotation at B, as you know very well, it is 4 EI theta B by L. It is 4 EI theta B by L. 4 EI theta B by L. Substitute the value of L as 5, it comes out 0.8 EI theta B. Now, at A, in A is fixed, there is no rotation at A, so theta A comes out to be 0. So the total moment at support B will be sum of the fixed moments at B and sum of because of the rotation at B. Because of the fixed moments and because of the rotation at B. Now it will be plus 19.2 plus 0.8 EI theta B. This will be equation denoted by capital B. Now, after considering one span, we'll go for the next span, that is BC. Now we'll consider the next span BC, in which here we find the rotation over here at B also and rotation at C also. So we'll have to consider all three types of moments at B and three types of moment at C. Which three types of moments? First, I am talking about the support B. So when we are talking about support MFBC, fixed moment at B due to the uniformly distributed load, it is equal to minus WL square by 12, it comes out to be minus 60. Moment due to B, moment at B, due to rotation at B, that is theta B, is nothing but 4 EI theta B by L, and L value will be 6, it comes out 0.67 EI theta B. Same figure that I am reproducing on this next page. Now moment at B, because of the rotation at C, theta C, will be half of the rotation at C, 2 EI theta C by L. It is 0.34 EI theta C. Now the total moment at B will be the fixed moments because of the UDL, then rotational moment at B because of theta B, and transfer moment because of the rotation of C from here. So we will find three types of moment that I have just mentioned over this. The total moment at support B is sum of the moment due to fixed moments plus moment due to the rotation theta B and rotation because of the rotation theta C. Now total moment we can find MBC is equal to minus 60 because of the fixed moments, because of the rotation at B, and because of the transfer of more rotation from C to B. Now we'll go for the next support C. Again, when we talk of support C, it has got again the clockwise moment because of the UDL, because of the half the rotation because of theta B, and full rotation 4 EI theta B because of C. So he has got three types of moments at C. Fixed moment because of UDL, it is plus WL square by 12, it comes out to be plus 60. Then rotational moment due to rotation at C, is equal to 4 EI theta C by L. It comes out 0.67 of EI into theta C. A rotation of moment due to rotation at B, theta B, which is a transfer, will be half of that, 2 EI theta B by L. It comes out to be 0.34 EI theta B. Now, the total moment at C is sum of all the three moments because of the UDL, because of the rotation at C, and because of the rotation of moment transferred to C. So it is plus 60 plus 0.67 EI theta C plus 4 EI theta B. This is alphabetically denoted by capital D. So we have calculated 4 total moments at A, B, C and D. That is for A, it is for span AB, it is for A, it is written as capital A. For BA, it is taken as capital B. For BC, it is taken as capital C. And for CD, it is taken as capital D. So 4 moments are that the supports has been calculated. Now, most important thing that you can see, you must have studied somewhere in the 3-moment theorem, in the moment distribution, and we have seen that at the intermediate support over here, the moment to the left is equal to moment to the right, and which is equal. So we can say sum of the moment at this point, that is BA, moment at BA plus moment of BC equal to 0, because this must be equal. Using this concept of the intermediate support has got equal moments on both sides, both spans. Now we also know that the sum of all the moments meeting at the intermediate support is 0, or we can say moment because of MBA, that is MBA plus MBC must be equal to 0. This is the important relation. This is the most important relation. Now, writing all the 4 equations, A, B, C, D, as we have already calculated previously, and applying the MBA plus MBC is equal to 0, substituting the value of all these A, B and C, D as per the requirement for B and BC, we are getting the relation between the E and D. And with the help of these 2 equations, where theta B and theta C are unknown, solving these 2 equations, theta B can be calculated and theta C can be calculated. The value of theta B comes out to be plus 54.89 upon EI, and theta C comes out to be minus 117.32 EI. Now, after calculating these theta B and theta C, substitute the value of theta B and theta C in equation A, B, C, D, and we can calculate the moments AB. It comes out to be minus 6.84 kilonewton meter, BA plus 63.11 kilonewton meter, BC must be same. Yes, it comes out to be minus 63.11 kilonewton, and we have seen if we substitute the value of all these over in CB, it must come out to be, then it comes out to be 0. So our all calculations says yes, our results are correct. And now drawing the bending moment diagram, we can say this is the fixed end moment at A, this is the fixed end moment at B, this is the final moment at C, this will give the WAB by L, and this is WL square by 8. So this way we can find out the final bending moment diagram. Thank you very much.